Good morning, good evening, good afternoon. Welcome, welcome, welcome. This is a makeup of the rocket that we missed from Vandenburg Air Force Base because, frankly, I was tired and didn't want to stay up until like 4:30 my time to watch it go. Um, so we're going to catch up on that. Before we do, I figured we'd take a look at it. Just for the record, the other launch still has not went off. Seems to be more than upper level wind shear, but that's still the word from SpaceX. So there seems to be a vehicle issue. Hopefully, they get it figured out. Um, so this is what we're looking at. We're looking at a Falcon 9. It's 70 meters in height, 229.6 feet. It has a diameter of 3.7 meters or 12 feet, and that is this main tank diameter, not to include the payload fairing. Its mass is 1,207,920 pounds, or 549,054 kilos. It can take up to 20,000 or 22,800 kilograms of payload to low Earth orbit. That's about 50,000 pounds of payload, so quite a bit. Payload to GTO and payload to Mars. The vehicle's not really used for it, so we won't until it is. We'll leave that alone for a minute. Why are you not letting me? So the first stage, it has those 9 Merlin 1D engines. So it consists of aluminum lithium alloy tanks to hold in that cryofuel. It has cryogenic liquid oxygen and rocket propellant 1, better known as RP1, better known as rocket grade liquid kerosene. It generates about 1.7 million pounds of thrust. You'll also notice on the bottom, there's a view of those 9 engines. Thrust at sea level is about 7,607 kilonewtons, or 1,710,000 pound-feet. So it has a lot of lift. And those are the landing legs that we see on the drone ship. Touching down on the drone ship. Here's our inner stage. It's a composite structure. It holds the top and bottom stages essentially together, and it has those beautiful grid fins that we all love to see. So this actually comes back with the Falcon 9. And we've seen that before. But this pushes away that first stage. So that's the first stage to return to Earth, the second stage to carry the payload to low Earth orbit. So the second stage of the Falcon 9 has this one vacuum optimized Merlin engine, optimized for the vacuum of space. It has a burn time of 397 seconds. So that's how much fuel and ability that engine has to burn. None of this is reusable. None of this comes back. It burns up in the atmosphere, and it's designed to do so. 981 kilonewtons of thrust, or 220,500 pound-feet. This is the lovely payload fairing. It can also be configured to take astronauts in the Dragon capsule, but our flight today will have the payload fairing. It has a height of 13.1 meters, or 43 feet, and a diameter of 5.2 meters, or 17.1 feet. Again, this is a carbon composite material, and this protects the payload on its ascent. It's jettisoned as soon as it possibly can to cut the weight, so that they can get more efficiency out of the rockets. Well, now that we have all that taken care of, we're going to get into the launch here. So this is the footage that's available. Again, SpaceX has been really good about only doing about 5 minutes of footage. That's all they seem to do on the front end. And then on the back end, they wait until the vehicle lands. This lands on my favorite drone ship. Of course, I still love you. But where we're going to pick it up is we're going to see that strong back retract. So all the critical things for flight have already taken place. They've already loaded RP1. They've already begun loading first stage LOX or liquid oxygen. They've already started second stage LOX, and they've already undergone engine chill, which we can see to the left-hand side here of this little thing that we got going on. So what we have coming up is strongback will be seen immediately. Then we will have command flight computer to begin pre-launch checks. After that, at the same time, we'll get tank pressurization for the flight. You get some of that boil off, so they have to repressurize the tanks so that everything works efficiently. About 15 seconds after that, we will get go for launch from SpaceX Director. Engine controller commands engine ignition sequence start at 3 seconds, T-3, and then T-0, of course, is liftoff. Same mission profile that we've been having with most, if not all, flights. The only difference is this one is going off Vandenburg Air Force Base, which is in Southern California. It is not leaving Kennedy Space Center. Well, I should say it did not leave Kennedy Space Center, because this is already well in space by the time I could get to it. My apologies for that, ladies and gentlemen. So we're going to pick it up at strong back retract, and the one interesting thing about Vandenburg is this is always how it looks. It is always ridiculously difficult to see anything at Vandenburg, which makes for some cool shots, but it is heavily clouded, especially when they do night launches. So we'll see what we can see. But so we get a good strong back retract, even though we cannot see it. Again, not uncommon. This is pretty normal for Vandenburg. You can see the lights out there. And again, this was at like 4-ish a.m. Eastern time. I think it was at 12:05 Pacific. So kind of middle of the night. So it's already dark to add on to the cloud cover. So we're just waiting on those callouts of fuel tanks full. But I also haven't heard any callouts yet. I don't know if they'll be doing them. You can barely see the puffy stuff because of all the fog. So this is always the interesting spot because not a whole lot mission criticals going on, but there's certainly some time where things have to go correctly. So probably the most concerning for the ground crews, but fun time nonetheless.
Stage 1 LOX load is complete.
Perfect. So we got a LOX. All right. So we got a LOX load complete. They'll start the closeouts of that stage 1 and closeouts of the ground systems that supply it with that liquid oxygen and RP1. As soon as we get the call out we're going to have a good RP1 call out, and then we'll have second stage LOX call out. A couple things while we have a second. SpaceX now has 261 total successful launches. 219 of those landed successfully. Some of them were accidental. Some of them were expendable rockets for larger payloads. And they've reflown 194 boosters at this point. After we see this one be successful. So they're doing great work over there, and it's impressive. So now we're getting that and behind the scenes, we're getting that go no go poll. Again, not as extensive as we saw with Lockheed the other day. They're much more lax about it, especially when it's a payload, especially when it's their own payload.
Load is complete.
So we got that stage 2 LOX load complete. So we should get those ground closeouts here very shortly, within the next 5-10 seconds. And that's just purging the lines so nothing accidentally catches fire or explodes on the ground. So there's our vent. So again, that oxygen is very cold. Southern California is semi-warm. So that gas will expand.
In startup.
All right. So we have a good Falcon 9 in startup. So now the rocket controls everything. The rocket is controlling all of the calculations and all of the tasks.
Go for launch.
And we are go for launch from the launch director. Go SpaceX, go Falcon 9.
T-minus 30 seconds.
So this is a payload of 21 Starlink satellites. So one less than normal. We normally launch 22.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition. And liftoff. Go Falcon 9, go Starlink Group 7-4, go SpaceX.
Vehicle is pitching downrange.
That's the
Stage
most
1 propulsion is nominal.
It's the most unenthusiastic announcer I've ever heard. So you see it punch into the clouds, and that's pretty cool. I think it's really neat that they have flight cameras on them. So now we're just in the ascent mode. So it's going to continue to pick up speed, continue to burn off that RP1 and liquid oxygen. We are coming up on max Q, where they will throttle down to punch the rocket through
telemetry nominal.
The maximum aerodynamic pressure. So that's where the atmosphere and the speed of the rocket are at their highest points of pressure on the vehicle. So if anything was ever going to happen, it would be right here.
Max Q.
MVAC engine chill has started.
All right, so they're chilling that second stage engine to avoid the thermal shock that would happen if they ran that very cold liquid through the engine. So they slowly cool it. We're about to have main engine cutoff, so all 9 Merlin engines will cut off here shortly. And then we'll get that separation from interstage, and the second stage will deliver the payload. The first stage will return back to the surface of the Earth and the drone ship. Of course, I still love you. So now, for all intents and purposes, in about 5-10 seconds here, it will be theoretically past the Kármán line, and it will be in space.
Main engine cutoff.
The Kármán line depends based on individual company, and nobody can really agree.
MVAC ignition.
So there's those huge titanium grid fins. Again, machined out of one solid piece of titanium to avoid breakage or undue stresses on the vehicle. We have a perfect view from the second. And there's our fairing separation, exposing our payload of 21 Starlink satellites to the vacuum of space. So on the right side here is that second stage vacuum optimized Merlin engine, or MVAC. On the left side is going to be that first stage booster that's doing its flip maneuver and returning to the surface of the Earth. So for all intents and purposes, the payload is in space at this point. But it has not reached its final orbital inclination or its final orbital insertion. So now we're starting to see that speed drop a little bit on the left-hand side. Again, that's going to be our first stage returning back to Earth. It will slow down kind of casually. Then we'll see it pick up a little bit more. And then we will have the entry burn, which is where they light. They usually light 1 to 3. It usually really depends. They write 1 to 3 of those Merlin first stage engines that will slow it down considerably, and then we'll start seeing it bleed off speed because it's re-entering the atmosphere and re-engaging the atmosphere. And there's our slight uptick in speed, so we're done with that flip maneuver. And it is carrying that momentum down. So very shortly we'll have that entry burn, and then you'll start seeing the speed come down. So
Nominal trajectory.
and trajectory is nominal, so good call out there. So that entry burn should be at 6:08, so it should be about 40 seconds from now, ish. 45 seconds, maybe. So once we begin that entry burn in about 4 seconds, we will see it burn for somewhere between 20 and 25 seconds, depending on what their data says.
Stage 1, entry burn, startup.
And there's our startup. Good startup from the entry. So you see that speed just bleeding off at this point. Like it is slowing quickly. And we'll see that even more dramatic once it starts encountering atmosphere after the entry burn. So
Stage 1, entry burn, shutdown.
and there's our shutdown of entry burn. So now we're just using our atmosphere to slow it down for us. You might see a little jump in speed depending on where they re-entered the atmosphere.
Nominal trajectory.
Stage 1, FTS has safety.
All right. So we got that little bump, and now, as you see, the speed is just bleeding off quickly. It's not uncommon for those cameras to get lost because of the plasma and really intensity of spacelight trying to get video signal back. So as you see, we have our speed coming down, our altitude is slowing down
Stage
as
1,
well.
transonic.
So our transonic back on the other side of 1250 kilometers an hour. 1300, 1250, somewhere in that general vicinity. As you can see, our first stage is almost landed. Our second stage is at about 22,000 kilometers per hour at an altitude of 166 kilometers
Terminal guidance.
over Earth.
Stage 1 landing burn.
So now we see that landing burn, and we'll see a touchdown on, of course, I Still Love You. Now, this is all autonomous. They communicate with each other. The spacecraft and the drone ship communicate with each other to determine where they're going to land. And just as normal, we have a
Stage 1 landing
perfect landing. So there's going to be the map, the orbital map.
MVAC shutdown.
And we have a second stage MVAC shutdown. So it is in space. It's where it's going to be. And another nearly flawless mission by SpaceX. They know how to do it for sure.
No,
So.
no parking orbit.
All right. Well, that is going to be it for this specific launch from Vandenburg Air Force Base in Vandenburg, California. Space Force Base, whatever it is now. So, we have the Psych mission, the Falcon Heavy Psych, leaving Cape Canaveral Space Force Station in sunny Florida tomorrow. I believe that's a 2:20 flight, but let me check real quick. Thought I had it up, but so for right now it is, they changed it. SpaceX and NASA are targeting Thursday, October 12th at 10:16 a.m. So it'll be an early one tomorrow morning. So we'll see what happens there. Hope to see you guys soon. Have a great day, and I will catch you later.